Hello again, this is my GCSE Science, and this is the last video on the topic of energy changes, for triple science or chemistry students only. In the previous video, we looked at chemical cells, which are basically batteries, allowing us to turn a combination of two metals into electrical energy. In this video, we're going to be looking at fuel cells. Fossil fuels are non-renewable sources of energy, but at the moment, around the world, we rely heavily on them. As well as coming from non-renewable sources, they also cause a lot of pollution. So the search is on to find a sustainable and non-polluting alternative. Hydrogen could be one of those alternatives, and it can either be burnt in combustion engines, in a similar way to fossil fuels, or it can be used in fuel cells to produce electricity without combustion. In the exam, as well as explaining how a hydrogen fuel cell works, you'll need to describe the main advantages and disadvantages involved with using hydrogen in a fuel cell. The main advantage is that the only waste product produced is water, so no pollutants or greenhouse gases come out of the engine. Fuel cells can also be any size, so can be used for a range of different uses, from really small to really large. They also don't need to be recharged using an electrical source, so if you're using it for a car, you wouldn't have to stop to plug it in every now and then. However, there are some drawbacks or disadvantages. One of the main ones is that hydrogen gas is a highly flammable gas, which means it could be really dangerous if it leaks, for example. Plus, hydrogen gas, as with many gases, is difficult to compress and store. In order to use it in your car, for example, you need to find a way to safely store the hydrogen gas so that it doesn't leak, while also allowing it to be delivered to the engine to make energy. Also, while it's possible to make hydrogen in a renewable way, sometimes it's produced from non-renewable sources, so although it has the potential to be a really sustainable fuel, that's not necessarily always the case. So let's look at how it works. The chemical reaction is the reaction between hydrogen and oxygen to make water, and you may notice that this equation is the same as the combustion of hydrogen. But in fuel cells, we don't have combustion, which of course means burning. Rather than providing a spark for the hydrogen and oxygen to react together, which is an explosive reaction, we keep the gases separate, allowing hydrogen to be oxidized without exploding. This oxidation reaction produces the potential difference, or voltage, which is the electricity that we want. But note that the hydrogen fuel must be supplied on a constant basis, and this is one of the challenges involved with developing hydrogen as a fuel. So here's a diagram of what a fuel cell might look like. We have the electrodes, which are made of graphite, that separate the left-hand side and the right-hand side. In this example, the left-hand side is the negative electrode and the right-hand side is the positive electrode. Which one's which all depends on which direction the electrons are flowing. They're flowing from left to right, which means they're going from negative to positive. In between the two sides, we have our electrolyte, which in a fuel cell is always alkaline, which means it contains hydroxide ions. So the hydrogen gas, our fuel, is supplied to the negative electrode, and the oxygen gas is supplied to the positive electrode. As the gases flow through the cell, they can diffuse through the graphite electrodes. On the left-hand side, the hydrogen reacts with the hydroxide ions in the electrolyte to form water, and this reaction releases electrons to the circuit. On the right-hand side, oxygen gains electrons from the circuit to form OH- or hydroxide ions again. To complete the circuit, the hydroxide ions move across from the right-hand side to the left-hand side so that the reactions can keep going as long as the fuel continues to be supplied. If you're in higher tier, you'd be expected to write the half equations that happen at each electrode in this fuel cell. So, hydrogen reacts with the hydroxide ion to make water plus electrons. Can you have a go at balancing this before I show you the answer? It's quite a difficult one. The first thing to recognise is that there's 3 hydrogens on the left-hand side and 2 on the right. So we're going to need to have an even number on the left in order to match up with the right-hand side. But if we just times the OH by 2, then we'd have too many oxygens. So if we put a 2 in front of the hydroxide, the water, and the electrons, then we have the same number of hydrogens, oxygens, and electrons on either side. On the right-hand side, the oxygen gains electrons from the circuit to form OH- ions. In this case, the water is included here to provide the hydrogen atoms needed to make the hydroxide. that water comes from the electrolyte solution. And to balance it, you may notice that there's 3 oxygens on the left-hand side and 1 on the right. But if we times the OH- by 3, then we won't have the right number of hydrogens. We times the OH- by 4, allowing us to times the water by 2 and the electrons by 4 to give us the same number of oxygens, hydrogens and electrons on the left as on the right. Now if you're just writing each of the half equations separately, then it's fine to leave them as they are. But if you're asked to write them both out, or you see them both written out in the exam, then you'll often see the left-hand equation doubled. Everything times by 2 so that we have the same number of electrons in the left-hand side equation as the right-hand side equation. If you're looking at each equation separately, they balance fine either way, but in all reactions that involve an electrical cell like this or electrolysis, in order for the circuit to be complete and to work properly, we must have the same number of electrons being lost on one side as being gained on the other side. And it's interesting to realise that if you put the hydrogen equation from the left-hand side and add it to the oxygen equation from the right-hand side, you end up with the original full equation that we started with. You can check that it all adds up right. We've got the 2 hydrogens on the left-hand side, the OH- ions, electrons, and 2 of the water molecules cancel out, leaving us with the 2 H2, 1 O2, and 2 H2O molecules that we started with. So I hope that wasn't too much of a slog. You've now finished the energy topic. Well done. Here's some keywords to add to your list. Thanks very much for watching, and see you again soon on the next video by My GCSE Science.